Okay, so far we've learned product rule. You have a formula, follow the formula, product rule. Then we have quotient rule, when two things are being divided. Follow the formula, do that. Now we're going to learn something called chain rule. Now, the first part of the presentation is all setup. So kind of sit back, listen, kind of see where it comes from. It's explaining how chain rule works, just like we explained product rule, just like we explained quotient rule, just like we explained all the special cases. Then we'll do a bunch of problems, okay? So our goal is to get to the problems, but the first part is setup. So kind of bear with me a little bit as we learn about chain rule, okay? So the way they start with a chain rule is they talk about composite functions. You may or may not remember this from college algebra, but if I had x squared plus 4 cubed, you could think of this as one function inside of another function. And that's all they're trying to say here. A composite function is one function inside another function. So if I look at the big function as something cubed, let's call that something u. You can call it whatever you want, but let's just call it u for now. So that's one function. And then what's inside is x squared plus 4. So one way to look at this is we have two functions. We have something cubed, which we'll call u. And what is that u? That u is x squared plus 4. So they're calling it composite as I have something inside, x squared plus 4. What is it inside of? It's inside of u cubed. That's all you got to get from that. It looks like a function inside of another function. Because remember, product rule was a function times a function. Now you know what to do. Quotient rule was a function divided by a function. Now you know what to do. What's this one? A function inside of another function. So if you get that, you're on your way. So if I had this, and again, just kind of follow along, we'll get to the problem soon. E to the u, that's the overall function. And we're going to put negative 3x in for u. So we have one function inside of the other function. So if my overall function is e to the u, and my function that I'm putting inside is negative 3x, what would that look like? It would look like e raised to the negative 3x. Nothing earth-shattering, but try to see it as one function inside the other one. One function inside the other one. And we use u to talk about that other function, whatever it is. And that's going to be something we learn later, u substitution. But it gives us a good opening. And it can go either way. So if I had 100 e to the 0.04x, we can look at it as one function inside of another function. One function inside of another function. We could think that the main function is 100 e to the u. And what are we putting inside of it? We're putting 0.04x inside the other function. So all you have to get is, what does this look like? It looks like a function inside of another function. It looks like a function inside of another function. Okay? So if I was taking this one, y equals square root of 4 minus x squared, what would you say the main function is? The square root of u. Let's just call it u. And what am I putting inside that function? 4 minus x squared. So I have one function inside of another function. So I can look at it as I have the square root of u, that's the main function, and u is what I'm putting inside, 4 minus x squared. So just get the idea of a function inside of another function. It's called a composite. A function inside of another function. Okay? So now we're getting to the power rule. And it looks like we did before. Remember, exponent goes in front, subtract 1? Well, that's what we're going to do here. An exponent goes in front, subtract 1. But it doesn't feel like we're done at this point. It doesn't feel like we're done at this point. There's one extra step. And what is that extra step? Yeah, the exponent goes to the front, rewrite it, subtract 1. But then what about the inside? What about that function we put inside the other function? You still have to take the derivative of it. You still have to take the derivative of it. So that's in general terms and symbols. But let's do an example, and it will all make more sense. Okay, so take that a nice for your paper. all of that setup is for this. Okay? So, if I look at this example, and I ask you to take the derivative, here's what you're going to do. If I ask you to take the derivative of this, you have to first look at it and say, is this product rule? Do I have two things or more things when we multiply by each other? Not really. Is it quotient rule? Is it two things being divided by each other? Nope. Is it the third one, which is what we're learning today, chain rule? Does it look like something inside of something else? That's chain rule. Okay? So, if you have something inside of something else, which kind of looks like I have something inside of another function, you can think of the main function as u to the 4, and what's inside of it? 3x minus 1. Okay? So first of all, we have to look at it and determine what it is. Is it product rule? No. Is it quotient rule? No. Is it something inside something else? Yes. And that's chain rule. Okay? So just by looking at it, we should be able to know that it's chain rule. And chain rule, once I go over it, you're like, I kind of like chain rule. Here's how chain rule works. Okay? Here's how chain rule works. The 4 goes to the front. Any questions there? Isn't that kind of what we used to do with exponents? Isn't that kind of what we always did? Then the inside stays the same. Inside stays the same. And then what do we do to the 4? What do we do to this 4 up here? Subtract 1, and what do you get? 3. Stop there. Doesn't this look like every example that we've done before with derivatives? Exponent goes to the front, inside stays the same, subtract 1. But here's the problem. Does it feel like it's done? Why not? We didn't do anything to the inside. So the last step is derivative of the inside. So what's the derivative of 3x? 3. What's the derivative of negative 1? 0. Stop there. You've just done chain rule. That's the whole lesson right there. When I have something inside of something else, or the way I like to do it is something to a number, then we use chain rule. Exponent goes to the front, inside stays the same, subtract 1, but you're not done yet, derivative of the inside. Stop there. Any questions on how I did chain rule? We're going to do a bunch of examples, but any questions so far? Now we're not done because of algebra. So to clean this up, what's the last thing I could do? 4 times 3, which is 12. Now stop there for a second. Let's talk algebra, okay? I simplified it. Can I go one step further and distribute the 12? No. Why? Because of the exponent. Remember your please excuse my dear Aunt Sally, all that wonderful stuff? Exponents come before multiplication. I would have to write this 3 times, multiply, simplify, and then multiply by 12. Now stop. Should I do that work? The question is, if I do all that work, would it be simpler than what I have now? No. And do you feel like doing all that work? Probably not. Are we leaving it in a nice simple form? Yes. Writing it 3 times and distributing and all that wouldn't make it any simpler. It would be a lot of work, and it wouldn't really help us. Okay? So now, all we have to do is practice. Okay? So here's your next one. Find the derivative of x cubed plus 4 raised to the 7th. And I'll leave the old one there. Okay? Again, it's not product rule. It's not quotient rule. Just by looking at it, it's something raised to a number. That means you're going to do chain. So you're just learning more techniques. You're learning product rule, quotient rule, and now you're learning chain. Okay, about 1 minute. Okay. So, not product rule, it's not quotient rule, it's chain rule. So what ends up happening? What happens to the 7? Go to the front. You keep your parentheses. Inside stays the same. The 7 becomes 6. And then we're not done because we need the derivative of the inside. What's the derivative of x cubed? 3x squared, derivative 4. Stop there. That's chain rule. Now again, I don't know how long. It could have special cases in it. It can get crazy. But the bottom line is something raised to a number, exponent goes to the front, inside stays the same, subtract 1, then derivative of the inside. Parentheses do matter. Would that be a final simplified answer? No, I can take it one step further. What would I get? 21x squared, x to the third plus 4 raised to the 6. Okay? Any questions? Now, the one little danger we had with product rule and quotient rule is if it's the easiest one possible, you can do it. But as soon as they put it in a negative or a fraction or a decimal or a special case, then we have problems. That's a different issue. Okay? But what we're learning is chain rule. Chain rule. Okay, next one. Let's say we have 1 over x squared plus x plus 4 raised to the third. Let's say we have 1 over x squared plus x plus 4 raised to the third. Your first instinct should be, oops, something's weird. But would it be quotient rule? You could, but remember how long quotient rule was? You could do it, but remember what we said, if it looks weird, what should be your first step? Rewrite it, then take the derivative. So look at this. You're going to have to rewrite it, then take the derivative. Look at it. You're going to have to rewrite it, then take the derivative. Remember, when you rewrite it, it's f of x. When you take the derivative, it's f prime of x. Now let's make sure we get the rewrite correct. So when I rewrite it, This will be in parentheses x squared plus x plus 4, but raised to the what? Negative 3. So rewrite it first. And that's algebra, exponents, we've covered it. You gotta know that. Then take the derivative. After a while, again, it's not memorizing. It's what is the pattern? What's the structure? What do we do with you? We're doing chain rule. We're not memorizing. Goes in front, subtract 1. We're going through a process. So when I take the derivative, the negative 3 goes to the front. Inside stays the same. Be careful. What does the negative 3 become? Negative 4. Am I done with chain rule? Nope. What's the derivative of the inside? 2x plus 1. And again, you got to know your derivatives. If you're still having derivative problems, you're still going to have problems here. It all builds. The derivative of x squared is 2x. The derivative of 1x is 1. The derivative of 4 is 0. Now, doing that means you got chain rule. But are we done? Nope. Let's clean it up. Let's talk about how we can clean it up. First of all, see that negative 4 exponent? How can I make it positive? It moves to the bottom, and the 4 becomes a positive 4. What else could I do to clean it up? I can distribute that negative 3 and get negative 6x minus 3, and that would be a final answer. Now, if somebody left it in the numerator as negative 3 times 2x plus 1, it would still be correct. I just think it looks a little cleaner to distribute it, but either way works. But again, chain rule, we had to rewrite it, then do chain rule, and then simplify. Any questions? Now, the next example we're going to do is the same stuff. Okay, so let's do one more example. Let's say we had 3x squared plus 1 raised to the 3 over 2. Bum, bum, bum. I raised it to a fraction. Does anything change? No. Take the derivative. Just because it's raised to a fraction, it's still the same stuff. It can be raised to a fraction, a decimal, a negative. All of them. All of them. Don't let it throw you off. Don't throw you off just because it is a fraction. Let's see how we're doing. Just because it's a fraction, nothing changes. 3 over 2 goes to the front. Inside stays the same, 3x squared plus 1. 3 over 2 minus 1 gives you what? Positive a half. Then the derivative of the inside would be 6x. Stop there. That's chain rule. Any questions? Then let's clean it up. If I do 3 over 2 times 6, again, you can use a calculator, whatever you want, but 3 over 2 times 6 gives you what? 9x. Then you can either write it as 3x squared plus 1 raised to the 1/2, or if you remember that 1/2 is the same thing as square root, either one's acceptable. Either one's acceptable because they're both the same. Now, the next couple that we're going to do, you're going to think is a review of special cases, and you can kind of look at it that way, but the reason why it works is chain rule. The reason why it works is chain rule. So take out your little sheet that has the special cases on it. Take out the little sheet that has the special cases on it. And I'm going to explain something that I kind of talked about before. Let's say I had e raised to the 2x cubed plus 5. Now, you may be saying, why is this showing up in chain rule? The reason why it works is chain rule, okay? So what we learned before is what's the derivative of e to the x? What's the derivative of e to the x? E to the x. Then I said, I added, hey, the way the book does it is they kind of stop there, but really there's one more step. Do you remember what that one more step is? So the derivative of e to the x is e to the x. But if you add something beyond that, what do you have to do? And the step is just like chain rule. Step 1, rewrite it, but it doesn't feel like you're done. What's the next step? What do you think the next step is going to be? And if you look at your rules, we talked about it last time. Step 1, rewrite it. Step 2, derivative of the exponent. Good. And it's kind of like chain rule. So what you're going to do is step 1, rewrite it. Step 2, derivative of the exponent. And again, it goes back to that idea of a function inside of another function, a function inside of another function. We have to take the derivative of the exponent. What's the derivative of the exponent? 6x squared, because the derivative of 5 is 0. And that would be your final answer. I would prefer, don't have to, but I'd prefer to put the 6x squared in front. You don't have to. Either answer is acceptable. Okay? So you may want to add this one. You already have it. But if you want to add another one to your special cases, if I had e to the 2x cubed plus 5, step 1, rewrite it. Step 2, derivative of the exponent. Step 1, rewrite it. Step 2, derivative of the exponent. They put it in chain rule. I like to show it earlier when we go over special cases, but the reason why it works is chain. Okay, so you get some good notes. And then what if I had ln of x squared minus 4x plus 2? Okay, first of all, is that a special case? Is that a special case? Yep. So we look at our notes. We have a good set of notes. Now, what we learned was ln of x. ln of x. What's the derivative of ln of x? 1 over x. Are we okay there? But then we said it may not always be x. It could be something longer, like this is. So we added to that and said it's 1 over x times what? times what? Derivative of the inside. So if you look at your notes, it's 1 over x times the derivative of the inside. So just like the chain rule, we take the derivative first. What's the derivative of ln of x? 1 over x. But this time, instead of having x, we have a little bit more. So what's the derivative of that? What's the derivative of x squared? 2x minus 4. Okay? So this, actually let's do this again. To take the derivative, it's 1 over, but instead of having x, we have x squared minus 4x plus 2. Okay? So step one, instead of having ln of x, we have 1 over x squared minus 4x plus 2. So it's always 1 over the original, 1 over the original, 1 over the original. This time we don't just have x, so we have that, times the derivative of it. And what's the derivative again? 2x minus 4. Sorry, I put it in the wrong place. Okay? So when we have an ln, it's 1 over the original times the derivative. Why? Just like chain rule. 1 over the original times the derivative. Okay? Because I put it in the wrong spot, let's just put one more next to it. Okay? So it's, let's say, ln of 4x squared minus 3x plus 2. Okay? So give that a try. What if I had ln of 4x squared minus 3x plus 2? Ln of 4x squared minus 3x plus 2. If you want to add this to your special cases, that's what you would have. The reason why it works is change. The reason why it works is change. So the derivative is going to be 1 over the original. Question so far. Times the derivative. What's the derivative of 4x squared? 8x. What's the derivative of minus 3x? Minus 3. And what's the derivative of 2? 0. So your final answer, I would write as 8x minus 3 over 4x squared minus 3x plus 2. And I'd probably add that to your special cases. I would put under special cases versus putting in a chain rule. The reason why it works is chain. But let's really make sure we understand. Okay? So here's 2 more examples. Do the derivative of e to the 2x and find the derivative of ln x squared plus 9. Let's really make sure we got those with special cases. So you're finding the derivative of e to the 2x, and you're finding the derivative of ln of x squared plus 9. Anyone add some notes, anyone write down step by step, whatever's going to help you remember after you walk out that door. Okay, so again, one at a time. So if I had e to the 2x, step 1, rewrite it. Step 2, what's derivative of 2x? 2. So I put the final answer as 2 e to the 2x. Either way is correct. I just think that looks a little nicer. Questions on that one? Next one. What is the derivative of ln of x squared plus 9? What's step 1? 1 over the original times derivative of the inside. What's the derivative of x squared? Derivative of 9. So I would put the final answer as 2x over x squared plus 9. And a ton of examples. Any questions? Now here's the concern. The concern is, do you understand chain rule, or are you just going through the motions? And let me explain what I mean. I'm going to give you one example, but before I get there, I'm going to do one more. Okay? So let's say I had 4x to the 5 minus 3x squared plus 7 raised to the 6. Let's just make that up. Okay? So if I had 4 times x to the 5th minus 3x squared plus 7 raised to the 6, can we all agree that this is going to be chain rule? Okay? So let's go through our steps. The 4 in front is going to stay in front, just like it always does. So 6 times 4 is 24. Does everyone see how I got to 24? Okay? Now, in words, tell me what the steps are. Exponent goes to the front. What's the next step? Next step? Rewrite the original. What's the next step? Subtract 1, which gives you. Are we done? What's the last step? Now let me say this out loud. The last step is derivative of the inside. Are we okay? That derivative can be easy, like the one we're about to do, and I hate to say easy, but easier, right? Or couldn't this inside have a special case? Couldn't this inside have a negative or a fraction or a decimal? Couldn't this inside be product rule? Couldn't the inside be quotient rule? Couldn't this inside be crazy? Yeah, because the process is exponent goes to the front, inside stays the same, subtract 1, and then whatever you got to do to take the derivative, what's the derivative of the inside? 5x to the 4 minus 6x. So understand that it's derivative of whatever's inside. That could be easier, that could be harder, that could be a special case, a product rule, quotient rule, it could be anything, but you know what you're supposed to do. Then, another problem people have is algebra. So how can I clean this up? Distribute the 24. Can I distribute it to the first one? Why not? Because of the 5. So remember, that's algebra right there. 24 times 5 is what? 120. X to the 4 minus, what's 24 times 6? What is it? 144x. Now again, this simplifying part is algebra, algebra, cleaning up, cleaning up. Is this a correct answer or incorrect answer? Is 120x to the 4 minus 144x times x to the 5th minus 3x squared plus 7 raised to the 5th, is that correct or incorrect? Would I take points off or would I leave it alone? I'd take points off. Why? Algebra, algebra. Why is this wrong? Right now, you're telling me 144x times this. That's all it is. What are you missing? Now, am I being picky or was it just wrong? And the answer is it was wrong. You have to have the parentheses. You have to have the parentheses. Okay? It does mean something else. It does mean something else. So again, number one, understand chain rule. And number two, be careful with your algebra. So here's our last problem. Okay? Let's see if we truly understand chain rule. 1 plus e to the x squared raised to the third. Okay? Follow chain rule. Follow chain rule. Exponent goes to the front, inside stays the same. Subtract 1 from the exponent, and derivative of the inside. Okay, so can we agree that this is chain rule? Just by looking at it, it's chain rule. Okay, so let's go nice and slow. What happens to the 3? Goes to the front. What happens to the inside? Stays the same. And then what happens to the exponent of 3? Subtract 1 becomes 2. Stop there. Any questions so far? Now, in words, what's the last part of chain rule? Derivative of the inside. Okay? So I'm going to do the derivative of the inside. Parenthesis. What's the derivative of 1? 0. What's the derivative of e to the x squared? That's a special case. So now we have chain rule, and within chain rule we have special case. So all these things can mix. So how do you take the derivative of e to the x squared? Step 1, rewrite it, e to the x squared times 2x. The derivative of the exponent is 2x. So all of these can start mixing, right? And you have this toolkit of special cases, product rule, quotient rule, and chain rule. You can do a chain rule within chain rule. Your mind just blew up. Okay? You told me derivative of the inside, whatever I need to do to take the derivative of the inside. So stop there. Any questions? Now, can we clean it up a little bit? What can we do to clean it up? What would I end up with? I can't distribute the 3 to the 1 and the x squared because of the x squared. But can I do 3 times 2x? 6x e to the x squared, 1 plus e to the x squared would be the final answer. Okay, and that ends chain rule. It is that whole